In this video, I'm going to use a matrix equation to solve this system. The augmented matrix that we used when we used the method of Gaussian elimination looked like this. A row for every equation. For our matrix equation, AX equals B, the matrix A is just the coefficients the variables are put into a column, so that's X, Y, Z, the variables from my system, and B is the column of constants. So here is my matrix equation, and I solve it like any matrix equation, no matter what size these matrices are. To solve AX equals B, I'm going to multiply on the left by A inverse. A inverse times AX, A inverse times B. And I have just X alone on the left, and my solution, A inverse B. So this involves finding the inverse for my matrix A, which is given here, and then multiplying the matrix B by that inverse. So with my matrices A and B, here's what it looks like. I have the variable matrix is equal to A inverse times B, which is 2, 2, 4. In the last video, I found out what the inverse to this matrix was using the Gauss-Jordan method. So I found that the inverse there, let me write it down here, was -4, 7, -1/2, 1, -1, 0, 2, -4, 1/2. And you can look back at that video to make sure that that was the inverse that we found. So to solve this system, all I have to do is multiply. And I have a 3 by 3 and a 3 by 1. I'm going to end up with a 3 by 1 as my product, and I have to fill in just 3 numbers. The first one is -4 times 2. I'll jot that down over here. -4 times 2, that's -8, plus 1 times 2, plus 2 times 4. So I get -8, +8, and 2 for that spot. In the next position, I have 7 times 2, plus -1 times 2, plus -4 times 4. So that's 14, and -18 will give me a -4 in that spot. Third position, I have -1/2 times 2, plus 0 times 2, plus 1/2 times 4. So that's 2 minus 1 gives me a 1. Let me get rid of all those little calculations over here. Now I have the solution sitting right there to my original system, and it is X equals 2, Y equals -4, Z equals 1. The work involved here was in finding the inverse. Then the whole thing just reduces to a multiplication, and I have my solution.